So Block shipped something in July and everybody called it Slack for AI agents. That's not wrong. It's just the least interesting thing about it. 23,000 GitHub stars. Desktop builds for Mac, Windows, Linux. Fully open source under Apache 2.0. And it's moving fast. Version 0.5.5 as of right now. Here's the repo. Let's actually look at what this thing is, what it genuinely solves that nothing else does, and where it'll bite you if you deploy it this week. Here's the framing that unlocks it. Buzz is not a chat app with agents bolted on. It's a Nostr relay wearing a chat interface. That single design decision is where everything interesting comes from. Nostr is a decentralized protocol built around signed events. Every message, every reaction, every workflow step, every code review, it's all one signed, append-only log. Not two systems, one. And here's the part most coverage skips. Buzz isn't just aiming at Slack. It uses the Nostr spec for Git events, so patches, branches, and approvals live in the same log as the conversation about them. No more context switching between two systems. Now on the agent side, it's genuinely model agnostic. Claude Code, OpenAI Codex, Block's own Goose, they all plug in through an agent harness called Buzz ACP. Same surface a human teammate gets. Shell commands, file edits, workflows, orchestrating other agents. So you can take Claude Code, which you're probably already using, and just drop it into a Buzz workspace alongside your team. Same tool calls, same capabilities. And Goose, that's Block's own open source agent. Native integration, obviously. The point is, you're not locked to one model family. But here's the problem nobody else has solved. You put more than one agent on a real code base. Something breaks. You have no idea which agent did it, or who told it to. Buzz's answer comes straight from the Nostr design. Every agent gets its own cryptographic keypair, not a label, not a username in a config file, an actual identity with Schnorr signatures underneath. Every action that agent takes, signed, attributable, traceable. And the design principle I'd underline, agents are scoped by identity, not permission flags. You add an agent to a channel the same way you add a person. No separate access control matrix for your robots. They're teammates in the permission model. I want to be fair about the size of this claim. Every other multi-agent setup I've used treats attribution as a logging problem to solve later. Buzz treats it as an identity problem and solves it at the protocol layer. That's a real contribution. Now that's the headline innovation. But there are a few other features here that are genuinely worth knowing about. Agents build up memory as they work. And because those notes live in the channel, not locked in one agent's private context, every agent in the room picks them up. Next session starts knowing what the last one figured out. You can even export an agent, memories and all, as a file. There's compute sharing, which lets you pool machines to host a larger model locally and point the whole team at it. If you're one of those people who bought a stack of Mac Minis for exactly this, it's built in. And then there's adversarial review. Honestly, this is the feature I'd use tomorrow. You point two agents at the same artifact. One attacks the design doc, one defends it. They go back and forth until the attacker runs out of objections. The whole argument stays in the log. And because you can run Claude against GPT, you get two different model families with different failure modes. That catches way more than one model arguing with itself. Right. Now the part that matters if you're actually thinking about deploying this. Because there are real trade-offs here, structural ones. Token cost is the big one, and the cause is structural. Buzz runs an agent session behind each participant, and that session already keeps its own history. When Buzz forwards a new message, it sends the history along with it, so you're paying for the same context twice. Add more agents, it multiplies. Testers have seen tens of thousands of tokens just to answer a greeting. Speed is the second issue. Work goes through the room sequentially. So for straight building, you're actually slower than just running your coding agent in a terminal where it can work several parts of a task at once. Here's the thing. That same property, every message being a signed event in one searchable log, that's what makes attribution work. But it also makes privacy complicated. The docs don't describe an end-to-end encryption story. If your team discusses anything you wouldn't want readable by whoever operates the server, factor that in. And look, version 0.5.5, 2,000 plus open issues. That's not a criticism. That's just what early looks like. Every problem I just mentioned is the kind that gets engineered away. The double context thing in particular, a fix waiting to happen. So should you use it? And the answer splits cleanly depending on one thing, whether you're working alone or on a team. Solo? Probably not. Your existing tools already cover it. You want parallel work? Sub-agents do that inside the subscription you're already paying for. Faster. Cheaper. You want models arguing with each other? You can orchestrate that directly. Adding a coordination layer just buys you overhead you don't need. But on a team, the calculus changes. And it changes specifically because of the attribution problem. Right now, if several people are running agents against a shared code base, you genuinely cannot answer which agent changed this and who asked for it. That gap is real. And Buzz is the first project I've seen actually close it. Here's what I'd actually do. Install it. Put 2 agents in a room. Run 1 adversarial review on a design doc you're already unsure about. That's a 20-minute test that shows you the best thing it does without committing your whole workflow to it. It's free. It's open source. The only thing it costs you is the tokens. Links in the description. Look, whether or not you deploy it today, the real takeaway is this. Treating multi-agent attribution as a protocol-level identity problem, that's the right call. And Buzz is the first to actually do it. If you want more breakdowns like this, subscribe. And let me know in the comments whether you're running multiple agents on a real code base yet. I'm genuinely curious how many people are past the experiment stage